yesterday, how many have you done physics problems? Once take out that work. I did not give means you have to do, no? I will keep quiet. You don't have responsibility. Why materials are given for you? Everything I have to tell her, you do this problem, you do this problem. Close the curtain properly. The material, the problems that are printed for you, not for us. When we are telling or not telling, you have to work every problem. Those problems are your problems. When we solve the problems, you will just watch. That's true. Every problem you only have to do. Then only we can ensure minimum 120 to 150 in final problem, final exam. Are you understanding? As of now, I don't know what is the status of yours, but one day I will check every problem in that material. Are you understanding? Simply, we are giving materials to not to keep in the cupboards. You have to do that every problem. Clear? Those problems are your problem, not my problem. Are you understanding? If I solve problems, you will not become doctor. If I solve problems, you will become an audience. Just you watch. Are you understanding? Okay. Whatever concept is completed, whether I give or not. Example, yesterday we have discussed the average current, RMS current, take out that material, search one problem, and you have to do. That is the attitude. You did not give me, that is not good. Are you giving also waste? Many times I gave always. No one is doing. That is showing your aimless attitude. Okay, anyway, we'll continue that alternating currents. Now here, today I am amping power. For example, if you take any circuit, for example, if you take any device and you connected one AC source, let's say the EMF applied across the AC source of this device equal to how much? E naught into sine of omega t. We don't know the status of that device. It may be resistor, or it may be inductor, or it may be capacitor. Sometimes they may be in the different grouping. Sometimes only few devices will present. Sometimes only series grouping is present. Sometimes series is present, parallel also present. As you don't know the status, okay? So I'll write the one arbitrary value of the current I is equal to how much? I naught into sine of omega t plus phi. Phi is the phase difference between the voltage drop and the current. Here phi value may be negative also. It can be a positive value or it can be a negative. This is called phase of the EMF. This is called phase of the current. You can treat the voltage drop and current also vector or phasor. What is the difference between vector and phasor? Vector means which is in the fixed position. Direction do not change. Direction means the angle between that vector and the x-axis is always constant. Now when such vector is rotating in the anti-clockwise direction, such vector is called a rotating vector or rotor or phasor. One should compulsory learn how to draw a phasor for different voltage drop. Now, if you see the voltage phasor for this, draw one y-axis and x-axis. What is the phase of this voltage drop? With the positive x-axis, how much angle it is making? Plus omega t. What is the meaning of the plus omega t? Many times I told it is an anti-clockwise angle. Here plus omega t is there means so this EMF or the voltage drop is maintaining how much angle? Omega into t with respect to x-axis, and the length of this vector is called peak value of the voltage drop or maximum value of the voltage drop. And if you look into this current phasor with respect to the x-axis, additionally 5 degree is made. So I can also draw current phasor like this. What the length of this current? That is equal to how much? I naught. How much angle it is subtending with respect to the x-axis? Omega t plus phi. What is the phase difference between the EMF and current? Phi. This total phase minus phase of the EMF. This is called phase of the current. Omega t is called phase of the voltage drop. So the phase difference is how much? Phi. You can say which is leading right now. Current is called leader and the voltage drop is called lagger. Why? Current is leading ahead and the voltage drop is lagging. So who is leading here? Current is leading. Everyone should learn this skill. Understood? It is a time-saving trick. Other than this phasor method, if you use, you can do the problem, but it will take a lot of time. Roughly, approximately, I am telling, if you strong enough in the phasor method, you can just solve the problem in 30 seconds to 1 minute. But if you don't use the phasor method, conventional method, the algebraic method, ordinary method, if you use, it may exceed 10 minutes, 20 minutes also. Understood? Now, tell me what is the power dissipated across this entire circuit? We will tell power formula. Total power equal to how much? Product of voltage drop into current. So I can write average power equal to what is the formula? We will tell average concept formula. Integration of how much? Instantaneous power into small amount of time interval and go divided by total time taken. All parameters that we created for only one full cycle. So what are the time boundary you have tried? From 0 to 1 time period. Now if you are not interested, T2, 2T also you can write. Understood? 90 T2, 91 T also you can say. Over a full cycle is enough. The time period should be T minus 0 should be capital T seconds. That is called one full cycle. Here also 0 to capital T. Tell me what is the instantaneous power equal to? Instantaneous voltage drop into instantaneous current into how much? dt. And volt divided by what integration of 1 into dt? Small t. And put the limits, what we can write? T minus 0. And the integration of what is the voltage drop at the time t seconds in the circuit? Peak value of the voltage into how much? Sine omega t into what is the instantaneous current in the circuit? I naught into sine of omega t plus phi and into how much? dt. Understood? And volt divided by how much? Capital T. Yesterday I have shown everything. No? Understood? You will get sine omega t into sine omega t how much? Sine square omega t will come. Understood? And one term will come sine 2 omega t. But the average value of sine 2 omega t will be 0. And the average value of sine square omega t you will get. That value will become 1 by 2. Understood? So if you simplify that, I am skipping that one because yesterday only I have explained. So directly I can write average power equal to how much? I can write E naught, I naught. You have to consider only sine square by 2. So directly I am writing 1 by 2 and into cosine phi extra it will come. Instead I have reduced. You might have been noticed. And in a standard format also I can write peak value of the voltage by root 2 into peak value of the current by root 2 into how much? Cosine of phi. What is this value? That is the RMS value of the voltage drop over a full cycle. So I can write RMS voltage drop and into RMS current into how much? Cosine of phi. It's a very, very powerful equation. Any different circuits with different devices, different grouping, directly we are going to use this power or average power over a full cycle. When we have to touch this formula over a full cycle only. Other than full cycle, you should not use this. Understood? If you use this, you will get the answer. That answer will be there in option, but it is the incorrect option. Be very careful. Over a half cycle is given means everything you have to do it. Conceptually in this method you have to do it. Understood? Now, very immediately, we will enter into the circuits. First of all, pure resistive circuit. What is the role of the resistance? What role of the resistance in iron boxes, water heater, geysers, etc.? Only to convert electrical energy into heat energy. There is no role other than this. It's a device which will convert electrical energy into heat energy. That's what. So that is a pure role. It will not store electrostatic energy like capacitor. It will not store magnetostatic energy like inductor. So that's what pure resistive circuit has written. And taking one, nothing is pure. It's the ideal case only. I will take one pure resistor hypothetically, and I connected to one alternate or AC source. At the time of t seconds, what is the voltage drop across cell as well as resistor? how much? Peak value of the voltage drop into sine of omega into t. For your explanation, I am taking sine of omega t. There is no rule, there is no protocol that you have to take only sine. Sometimes cosine also will be coming. If you switch on at a particular time, t seconds, let's say this polarity is positive, this polarity is negative, then how current will come? Current always will be coming out of the positive terminal and going towards the resistance. Then here also high potential to low potential, always current will flow. Understood? Here I can write directly voltage drop across cell must and should be equal to how much? Voltage drop across the resistance. What a voltage drop across cell? How much? E naught into sine of omega into t. And that equal to, tell me what the voltage drop across resistor according to Ohm's law? Instantaneous current I into capital R value I am sending this side. So what will happen? So what is the current at any time t seconds equal to how much? How much? I is equal to how much? Peak value of voltage drop by resistance into sine of omega t. This is called peak value of the current flowing in the circuit. So I can write current at any time t seconds equal to how much in the resistive circuit? I naught into how much? Sine of omega t. You people respond. What is the phase of the current? Phase of the current equal to how much? Omega into t. And what is the phase of the voltage? Also omega into t. So what is the phase difference between the voltage and current? Omega t minus omega t, how much? 0. Then how you can write the phasor diagram? Draw the x-axis and y-axis. Who is the leader? Both are leaders only. Why? Because phase is plus omega t. That phase also plus omega t. What is the voltage phasor? Respond. This is the voltage phasor. Its length is V naught. How much angle it is making? With x-axis omega t. How do you draw the current phasor? Also here only na. We say yes or no. Because current phasor also making omega into t angle. So the current phasor also omega into t. As they are pointing in the same direction, instead of x-axis, I can also draw like this. This is the current phasor and this is the voltage drop across resistor phasor. This is a very important point. Everybody have to remember. Always in any kind of circuit, total current phasor and voltage drop across resistor both must be in the same phase. What is the concept of same phase? If this current is maximum, voltage drop across resistance also maximum. If this current is 0, voltage drop across resistance also 0. If this current is negative maximum, it's also negative maximum. That is the meaning of the same phase. Out of phase means what? If this is maximum, this need not to be maximum. It can be some other value. It can be minimum value. It can be a positive minimum. It can be a negative minimum. Not compulsorily a minimum. Not compulsorily a maximum. It is own choice. Depends on the phase difference. They will be in the out of phase. Understood? This point is very important because oncoming applications, when I am drawing phasor diagram, directly I will write that you should not be new thing. Understood? Now Tell me how we can draw the current phasor also. This is also current phasor. This is also voltage drop across resistor. You can also draw like this. You can also draw like this. This is the current phasor. This is the voltage drop across resistor. There is no rule that you have to draw in some particular orientation, but for a systematic description, in oncoming application, I will draw this is the current phasor, and this is what voltage drop across resistance phasor. Horizontally, I will take along x-axis. Now tell me what is the power dissipated across resistance or average power? Power I am talking means you have to understand that is the average power dissipated across resistance. How much that is? How much? Formula I told just now. IRMS and into IRMS into cosine of 0. Because phase difference between current and voltage how much? 0. Cosine 0 value how much? +1 means maximum. So your average power also will be maximum when only pure resistor is present. So what is the maximum value? E0 by root 2 into I0 by root 2. So I can write E0 into I0 by 2. This is the maximum power dissipated across the resistance. So point clear everyone. This is the complete analysis and especially phasor method also. And questions will be coming in the wave form also. What is the EMF versus time plot? Sorry, voltage drop. I am plotting on y-axis. Time I am plotting on the x-axis. What is the waveform? This is only the waveform. And even current versus time plot also, if you look, it will be also in the same waveform. Because both are same equation only. Now, what is the voltage drop across resistor? E0 into sine of omega t. What is the current in the wave? Current in the resistance also sinusoidal format only na. So it will be also same format like this. Have you noticed at the same time current is minima, current is maxima and voltage drop also maxima. Here at this time if you look, current is minimum and the voltage drop also minimum. That is the meaning they are in the same phase. Same phase means this growing means it is also growing. Out of phase means as it is growing, it is decaying. That is the meaning of the out of phase. Understood? That is a complete analysis of the pure resistive circuit. It is a hypothetical circuit only. In reality, less or more, every resistor will show some inductance behavior. Is there a rule that only wire should be straight line? No. It may be somewhat curved like this also. No? Microscopically, if you look, means it might trap some magnetic field lines also. Understood? So it will show in reality I am talking. In reality speaking, nothing is true. It may partially shows the inductance nature, partially also may shows the capacitive nature also. Now, next kind of circuit is pure inductance. What is next one? Pure inductance circuit. Pure inductance circuit. This is one inductor of coefficient of self-inductance L Henry, and I am connecting to one AC source. What is the voltage drop at any time t seconds equal to E0 into sine of omega t. We are observing at the time of t seconds. At any time, this is the high potential and low potential. So current is coming out of the cell like this and entering like this. So here also I can write voltage drop across cell must be equal to voltage drop across inductance. Why? Because both are in the parallel combination. What is voltage drop across the cell? E naught into how much? Sine of omega t. What is the voltage drop across inductor? How much? L into di by dt according to Faraday's law of electromagnetic induction. dt I am bringing this side. You bring dt that side. What I can write? L into di is equal to how much? E naught into sine of omega t into dt and integrate on either side. But integration of 1 into di will be instantaneous current at the time of t seconds and here E naught by L into but integration of sine of omega t minus cosine of omega t and whole divided by differentiate this term inside the denominator. So omega will come like this. Omega will go this side. So, but EMF, I mean voltage drop is we have taken sine, but current we got cosine. So it is not a advisable format to comparison. Both should be in the sinusoidal only. Then only very comfortable for us to compare its phases. So immediately I will convert into sine. How you can write minus cosine into sine? Cosine omega t means sine of how much? Omega t minus pi by t. Omega into L. So it is not sine 90 minus omega t. Sine 90 minus omega t, if you write up, it will be plus cosine will come. That's what I have written. Omega t minus 90 I have written. I told you many times it is similar to current term. Dimensionally, this is current means this is also current. And this denominator is always representing equivalent resistance, but it should not call resistance. It is called opposition, and the technical term is called reactance, inductive reactance. I told you many times the nature of the inductance as the original current in the circuit is increasing, number of magnetic field lines also increasing, but it will show its opposition. The total opposition is called inductive reactance according to Faraday's law of electromagnetic induction. This is called XL. XL means what here? Inductive reactance. Its value how much? Omega into L here. If you observe this current, we got negative sign. What is the meaning of that? Current is lagging. Who is leading? Voltage drop across inductor is always leading. Then how do you draw the phasor diagram? I can draw like this. This is a voltage drop across inductor or voltage drop across the battery. C means what? Cell here. Then what is the phasor diagram of the current in the circuit? Leading or lagging? Lagging. This point everyone have to remember. This is the current in the inductor. It's always lagging by how many degree? 90 degrees. Understood? Do you feel the possibility of the pure inductance? No. Why? Every inducting wire is made of less or more. It's a wire only. So every wire in reality less or more have some resistance also. Understood? But it is a hypothetical case only. You people respond, what is the average power dissipated in cycle, in one full cycle? What is the formula? What is the formula? Over a full cycle only I have talked enough. So confidently I can take RMS voltage and into how much? Cosine of phi. What is the phase difference between current and voltage? 90 degrees. So I can write average power equal to how much? 0. As there is no resistance, there is no dissipation of power. When power will be dissipated? When there is a resistor. When there is a friction between charges and copper atoms, then only resistor atom, then only some energy will be dissipated in the form of the heat. So as of now, there is no power dissipation because of the phase difference is how much? 90 degrees. Then the wave format also, if you see the voltage versus time graph, this is the graph like this. Then how will you plot the current versus time? Very clearly, when voltage drop is maximum, current will be, you got negative cosine. No? Have you noticed here? It is a negative cosine only. Na? I told many times, what a negative cosine curve will be like this only. Na? There should be careful. This is a negative cosine curve. I mean, when the voltage drop is maximum, what will happen to the current? What will happen to the current? It will be 0. No current will flow. And when EMF is 0, and the current will become maximum. When EMF is negative maximum means current become 0. That is the meaning of the out of phase with the 90 degree. That is the meaning of the lagging of the current. Okay, that is a hypothetical circuit called what? Pure inductance circuit. So pure inductance over what next? What next? Pure capacitive circuit. If you look into the pure capacitive circuit, this is also hypothetical concept only. I will take one idealized capacitor, but in reality, no capacitor will exist without any resistance. And I am connecting to one alternator. Let's say its capacitance is C. Let's say the voltage drop equal to how much? E naught into sine of omega t. Let's say we'll observe at the time of t seconds. This is high potential and low potential. And here the current is also going like this. Directly I can write voltage drop across cell must be equal to how much? Voltage drop across capacitor. What is the voltage drop across cell here? E naught into sine of omega t. You people know what a voltage drop across capacitor? This is our capacitor. That how much? Plus Q by C. Let's say Q is the at any time t seconds charge on the capacitor. Capacitor means only our left plate. That's what strictly I have written positive Q. And what is the instantaneous charge on the capacitor? Here, what is the instantaneous charge on the capacitor? Q is equal to C into E naught into sine of omega t. By seeing these two equations, voltage drop across capacitor and charge on the capacitor, both are in the same phase. Phase is omega t means this phase also omega t. What is the meaning of that? If voltage drop is maximum, charge also maximum. This is 0 means this is also 0. That is the meaning. Charge and voltage drops across capacitor always in the same phase. I will write that point. Phase difference between charge versus potential drop is always 0. Anyway, we are not working on instantaneous charge. We are working on the instantaneous current entering into the capacitor. Shall I write instantaneous current equal to increment in the charge on the capacitor at that instant and divide by time. Substitute this Q value. What I can get? D by dt of Q value how much here? Q value how much? C into T naught into sine of omega t and what is the current here? This I will take outside. So C into E naught into what differentiation of sine of omega t plus cosine omega t. Again, you have to differentiate second time in the numerator, not denominator. When you are doing integration means denominator you have to do the differentiation, but it's already differentiation na. So in numerator only you have to do. To differentiate omega t, what do you get? Omega will come. Omega into dt by dt will be 1. So I can write current at the time t seconds equal to how much? E naught by omega c. Shall I write like this? 1 by omega into c. I told you many times this specific term is representing peak value of the current. Means this denominator representing opposition created by the capacitor. Definitely you will have one doubt, sir. How do you say that opposition, sir? So, for example, when fresh charges are entering into the capacitor, already existed charges will repel them because like charges repel each other. That sum of the opposition by all the existed charge on the plate towards the fresh charges or entering charges is called what? Capacitive reactance, or generally it is called capacitive opposition. Understood? This total term is representing the opposition of the capacitance. It is called capacitive reactance or impedance also. Here we have one device only, so we have to call that total opposition is called reactance. But in the oncoming application, I am going to introduce multi-devices. Understood? Vector sum of all opposition is called impedance. All of these are vectors only, no? Yes or no? Everything is vector. Current is a vector, and phasor, rotating vector. Voltage also phasor, power also, and impedance, reactance, everything is a vector quantity. Yes or no? Understood? So compulsory. See this omega I am taking this side. It is a called capacitive reactance. That value how much here? 1 by omega into. See, it is a memorized thing and into how much? Cosine of omega t. Cosine, immediately you have to eliminate. How will you write in the terms of time? Respond. How will you write? Omega t plus 90. So I can write current equal to how much? This entire term is called what? Peak value of the current in the pure capacitive circuit. That is equal to how much I can write? Sine of omega t plus pi by 2 I can write. This is the phase of the current in the pure capacitive circuit. The leader diagram. Current is leader here Understood? Who is lagger? Voltage drop is lagger. How do you draw the phasor diagram? Always voltage drop across the capacitor should point the x-axis, and the current will be leading. The current flowing in the capacitor always leading. Plus is there now? Plus means anti-clockwise. That's what it is upside. Is it clear here, everyone? Okay. And now power comes. Average power dissipated. Logically also we can answer. Understood? You don't need to any mathematical justification. What is average power dissipation? Is there any wastage of energy here? Power dissipation means wastage of power. Is there any wastage of power? When power will be wasted? When resistance present. Correct or not? This is it's the idealized case. Directly I can write average power dissipated how much? 0 over in a full cycle. Or else you can have the mathematical justification also. But average power dissipated equal to ERMS into IRMS into cosine of 90. Pi value phase difference is 90 degree only na. Angle between this current phasor and voltage phasor is 90 degrees, so it will be 0. Understood? Logically also you have to remember. Now we will come to the real circuits. Real circuit means real circuit means if you take one inductor here, friends, definitely it will have some internal resistance. So the concept of cell only I have told. When inductor came or cell came, internal resistance, you have to represent the right side on. Or you should not feel it is the external resistance, it is the internal resistance of the self inductance, and you have to connect one cell. Let's say the voltage supplied by the cell equal to how much? E naught into sine of omega t. Understood? Now here directly I am going to use the Phasor method. You see, I told you many times. Let's say the total current in the circuit is I means. How to draw the current phasor? Tell me. Current phasor always you have to draw on the x-axis only. Current. Remember this point. You write also no problem. Current phasor. Do what I said only. Understood? If you execute your own method, I will be not responsible. Compulsory the current phasor and voltage drop across resistance must be along the x-axis. So I have drawn current phasor on the x-axis. Now tell me voltage drop across inductor leading or lagging? Only you focus on inductance. Just now we have finished in the previous case inductance. Current is lagging. So the voltage drop across inductance is leading. Then what about the voltage drop across resistance? Many times I told voltage drop across resistance and current in the circuit both must be in the same direction. Understood? The strategy you should know. Then I will take only voltage phasors. So this is the voltage drop across resistance phasor. This is what voltage drop across inductance phasor. Let's say this is the total voltage applied by the cell. As I consider the vector quantity, I will construct one parallelogram of vector addition or rectangle. What is the resultant voltage drop here? To draw any diagonal that is representing what here? Voltage drop across the entire LR circuit or voltage drop provided by the battery. So here what I can write voltage drop across battery. Look into this voltage drop. V, what I can write? Voltage supplied by the battery equal to how much? CL square. Voltage drop across inductance square plus voltage drop across resistance whole square. According to Ohm's law, what a voltage drop across entire circuit? Total current in the circuit at the time t seconds into total impedance. When multiple devices are present in the circuit, you have to use the impedance. Should not use reactance. What a voltage drop across inductance? I into XL whole power 2 plus. What a voltage drop across resistor? I into R whole power 2. Here I square cancels out. What a total impedance of this LR circuit? Under root of XL whole square plus R square. You can also write total impedance equal to total inductive reactance. Very good. Omega into L. Omega into L whole power 2 plus R square. This is the total resistance also you can write. Total impedance also you can call. Nothing will happen. And what is the phase difference between this current in the circuit and net voltage? Because of the inductance, this is called inductive dominant circuit also. Because of the presence of inductance, voltage is leader, current will be lagger. What is the phase difference between them? Not 90, not 0, less than 90 and more than 0. Maybe 30, 45 like that. Then how will you find the phase difference? Tell me. I can use tan of pi equal to how much? Opposite side by adjacent side. Like voltage drop across inductance by voltage drop across resistance. So I can write here tan of pi equal to what is voltage drop across inductance equal to I into XL divided by I into R. I cancels out. What is the phase difference between the two things? I mean current and voltage drop. Tell me. Phase difference pi is equal to how much? Tan inverse of XL. XL means what? Omega into L divided by capital. Then how can you write the current in the circuit at the time of t seconds? When you apply the voltage drop not into sine of omega t, how much current is flowing in the circuit? How much current is flowing in the circuit? I naught into sine of omega t. Because of this inductance dominant, current will be leading or lagging. Lagging, so I should put minus or plus. Compulsory I have to put minus pi. What is the pi value we found? Tan inverse of omega L by R. This is the expression for what here? Instantaneous current in the circuit. What about the average power? Respond. What is the average power here? You know the direct formula. RMS voltage into RMS current into cosine of pi. So I will keep like this only. RMS voltage into RMS current into what is cosine pi value? This cosine pi also called as power factor. Because the how much power dissipated, more less, zero, minimum decided by this cosine pi only. So this cosine pi is called what here? Cosine pi is called power factor. What is the power factor value here? Use that triangle. Just now I told this is what voltage drop across resistance phasor. What is this phasor? Voltage drop across inductance phasor. What is this phasor? Respond. voltage drop provided by the cell. Shall I write? This is inductance, reactance phasor. Everything is phasor. Current, voltage, reactance, impedance, everything is vector quantity. This is what? What is this? This is called resistance phasor. According to parallelogram law of extradition or triangle law of extradition, this hypotenuse representing total impedance. And as usually, what is this? Phase difference between current and voltage. Now you tell me cosine phi value how much? Adjacent side by hypotenuse. Here also you can take, no problem. Cosine phi equal to adjacent side by hypotenuse also you can. Understood? If you take like that, what do you get? Average power dissipated equal to how much? This is R by Z directly. Okay. Over a full cycle, and it never be zero. Should have that confidence. Where there is a resistance, compulsory should be very confident. Compulsory less or more, some power will be wasted or dissipated. Now it is your turn. Everyone, repeat the same thing for impure capacitive circuit. What is the meaning of the impure capacitive? Pure capacitor will come. Every capacitor plate is made of metal. Every metal will have some internal resistance. So its internal resistance, beside only you have to draw and you have to connect one voltage, alternative source. What is the voltage drop at the time t seconds equal to E naught into sine of omega t. Now my first question, find the phase difference between current and voltage. My second question, what is the current flowing in the circuit at the time of t seconds? My third question, what is the charge stored on the capacitor at the time of t seconds? My fourth question, what a voltage drop across capacitor at the time of t seconds? My fifth question, what a voltage drop across resistor after t seconds? My sixth question, what is the average power dissipated over a full cycle? Your time starts. Use the phasor method. See, you might have been noticed, I have used only phasor method. I did not write big algebraical or differential or integral equation. I never used. That is the useful of that phasor method. One should follow this method also. Understood? Series CR circuit or impure capacitor circuit. Friends, tomorrow holiday. If I take one class for any objection, online only. Online, just 1 hour or 1.5 hours. No problem, na? Then you tell the time. My 1.5 hour time definitely will not affect your celebration time. Time you are thinking. Evening you have to go to temple. I also have to. For temples we should go. Morning 9 hours. 9 I will not get up. 11 o'clock is good. Early morning. Early morning. By that time I will sleep. No. 10 to 11 or 11:30. 10 to 11:30. 9 hours. Daytime. Today you want 9 to 10:30. Okay, tomorrow I asked you suggestion. That is my biggest mistake in my life. Okay, 10 to 11:30 tomorrow. Morning would be good. Afternoon 2 to 3:30. Okay. Okay, fixed. No more discussion. 2 to 3 or 2 to 3:30. Okay. Okay, so tomorrow, everyone, 2 p.m. to 3:15 or like that. Okay, 3:20. These are timings. Okay, I will share the link also. Okay. Now, friends, please concentrate. Shailesh, tell me if you switch on the current, let's say the total current in the circuit, how many amperes? Let's say I ampere. We should depend on the phasor method only. We should never go for any algebraical method. It's a very time wasting method. So I will use the phasor method only. What is the current phasor? This only, na? It's a yes or no? This is current phasor as well as voltage drop across resistance phasor as well as resistance phasor also. This is a very important thing to draw the phasor method. Now tell me what is the voltage drop across capacitor? Leading or lagging? You can tell me. Lagging. When only capacitor is concerned, the capacitor current is always leading, voltage is lagging. So current I have drawn here, na? So DC should be drawn like this. The voltage drop across capacitor. What about resistor? I already drawn here. So I will unify only DC and VR. This is what? VR, and what is this? DC. I am going to use the parallelogram law, vector addition, or rectangular vector addition, or simply triangle law. I will construct one parallelogram, but it becomes rectangle. The diagonal is representing what here? Voltage drop supplied by the cell or across the circuit. What is this? Clockwise angle meaning? I told many times. Clockwise angle meaning lagging. I mean this voltage is lagging to the resultant current. That is the role of the capacitor. In any circuit, if capacitance is dominant, current will be leading, voltage will be lagging. Tell me what is the net voltage? What is net voltage, friends? According to Pythagoras theorem, what is net voltage? V is equal to how much? Under root of DC square plus D R square. What is total voltage across the combination? Total current into total impedance. That equal to how much? Total current into inductive capacitance and whole power 2 plus I into R whole power 2. Why I am taking same current? All are in the series grouping. Rule is same current should flow. So here I square is getting cancelled out. So what is the total impedance of this impure capacitive circuit? Under root of how much? Xc means what? 1 by omega c whole square plus R square. Then how will you draw the reactance phasor also? Reactance phasor, how we can draw? This is a resistance phasor. What is this phasor? Inductive, capacitive, reactance phasor. Construct one parallelogram. This diagram is representing impedance phasor. You can convert in terms of unit vector also. How you can represent? How you can represent every vector into unit vector? Here also impedances, resistance, currents, voltage drops. You can apply all vector rules. Understood? Now tell me, what is the phase difference between this current phasor and net voltage phasor? Pi only. How will you find tan pi equal to how much? Tan pi equal to how much? Opposite side voltage drop across capacitance by adjacent side voltage drop across resistance. No, you can also write capacitive reactance by resistor or resistance. What is XC value?
1 by omega.
1 by omega c. So I can write phase difference between current and voltage how much? Tan inverse of 1 by omega into c into R. Understood? What is the average power dissipation? Definitely it is not zero. Why? Resistance presents definitely some energy wasted, dissipated, but average power equal to RMS voltage into RMS current into cosine phi. What does cosine phi means? R by Z. Z value how much? Under root of XC whole square plus R square. Tell me the total current flowing in the circuit at the time of t seconds. Please respond. What is the total current flowing in the circuit at the time of t seconds? Peak value of current. What is peak value of current? Peak voltage by total impedance. And into how much? Sine of current leader or lagger? Leading, very good. Because here you can see the Phasor diagram. It is above the voltage, so it is the leader. Plus half rate or minus half rate? Plus half rate omega t plus pi half rate. What is pi value? Tan inverse of 1 by omega c into R. That is the current flowing in the time of t seconds. Next one, voltage drop across capacitance at the time of t seconds. How I can draw this? How I can draw? What manner? All are incorrect. This book one. What are you telling? Doubt. Okay. Tell me what a voltage drop across capacitance. Tell me everyone. At the time of t seconds. How much Q divided by C? I mean you have to find the charge at any time t seconds. How will you find the charge at any time t seconds? I don't know. You are expert, not telling me. Q is equal to how much? Integration of instantaneous current into Pt and divided by C. I am leaving this as a homework to you. Try in your house. Okay. And some problems I will give you. Give me one material. I will go, ma. And definitely I will not stay here. Understand? I too have lot of work. Amma, please write now page number 264. Page number 264. Page number 264, question number 9, 10. Only one time I will tell. Page number 264, question number 9, 10, 15, 19. Page number 265, question number 25, question number 23. Page number 267, question number 42. Ma, that things only you have to reduce the section. Page number 273, question number 9, 8. The same page 12. Page number 274, question number 19. Yesterday we discussed the as is model. Page number 274, question number 19. How many? 15. After 15 completed, stop me. Page number 275, question number 29. Page number 277, question number 49. The same page 50. Page number 276, 40. Okay, friends, thank you. Take 5 minutes break. Today, Super China test is there. Hello, everyone. Ma, 1 minute, ma. I will go early, please. After botany class, study hour is there. Again, my class also, you can prepare for Super China or whatever you want. Today, Super China test is there, 5 to 8 o'clock. Understood? Top 15 compulsory, they have to write. Remaining students optional. Top 15 means I will tell also. Vishwa, Kavi Bharati, Srinidhi, Sri Shailesh, Vajika, Jivika, Bharati, Srinivas, Kritika Sri, Uma Priyadarshini, Tejasri, Paulson, Tamim, Naveen, Varshni, Yashika, Surya, Arshit. The Lord knows that 2 weeks before you want, huh? Once again, fresh one I will tell. Or else estimate average shall I go? Estimated average is good one. Estimated average. Why are you bothering about Bharati? Yes. Now I got estimated average. Jivika, Atarik, Srivarshika, Srinidhi, Harshit, Srinivas, Sri Shailesh, Bharati, Vajika, Kritika Sri, Uma Priyadarshini, Vishwa, Niveda, Gokulavani. How many numbers count? Gokulavani, Said. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Correct. These students compulsory have to write, and few more students also I will tell. Those also have to write. What ma? We'll go. Then I will take class. No problem, na? You take the question paper, then how will you send? You have to tomorrow holiday, no? You will scan, huh? In NLAN app, it is activated. But for you are not Super China batch, then today you write, ma. Today alone, next week onwards you go. That I am assuring, na. Tomorrow holiday is not there means. We I told many times, Super China test. Watch, open the WhatsApp group. I informed or not. April 13, Super China syllabus. Bring extra snake. I said or not. Understood? 10 hands I said. It is a incorrect information. I sent. I will be perfect only. Last week I understood. Okay. This week, ma, as per next week onwards, I am only telling. Now you can take that. No problem. This week alone, please write the test. Request. Stay here today alone and write. What, ma? Okay, today these red students compulsory have to stay, and 5 to 8 they have to write the test and they have to go. That's all. I did not inform. It is a wrong statement. I informed 2-3 times. I informed. Understood? Okay. Okay, student. Thank you. Already. Now take 5 minutes break. Thank you. Bye.